and welcome to this panel on From Data to Models, focused on the evolution of AI infrastructure. So it seems pretty crazy that we were all here a year ago, and it seems like time has completely flown. But within that time, there's been a renewed focus on AI. And what, during the last decade of the 2010s was really the focus within the data infrastructure stack that moved from on-prem to cloud. Now seems like the 2020s is going to be characterized by modifying that stack to support AI efforts within the enterprise. So 75% of CEOs are now saying AI is their #1 priority. And so the real question is, how does this $250 billion data infrastructure space evolve to support those priorities? So hopefully today on this panel, we'll explore a little bit of how you can think about building a stack internally within an organization, how founders and investors can think about success within this space, and then for everyone else, give you guys a little bit of a glimpse into maybe less lauded but just as important part of the AI equation for achieving ROI. So with that, I will kick it off and turn to our panelists and allow them to introduce themselves and maybe speak a little bit about the problem that you're solving and who you're solving it for.
Yeah. Well, thanks. Hi, everyone. I'm Brian Raymond, founder and CEO of Unstructured. And so Unstructured, we're about an 18-month-old startup, but we've been focused on the language model space from the get-go. And it was really the lived experience that myself and our engineers had at prior companies that led to us starting Unstructured, which was between 2018 and 2022, you couldn't walk more than 10 feet in San Francisco without finding another data labeling startup or a model management, model serving startup. There was nobody to help actually take enterprise unstructured data and then render it into a format that was model ready. And so in the summer of 22, when we kicked it off, we were 100% focused on kind of the Hugging Face community and around small language models at the time, or medium-sized language models. And then ChatGPT happened and RAG happened, which we'll get into, and really increased demand for data that's today used to fine-tune language models, as well as to put it into vector databases for retrieval augmented generation. So simply put, we're taking any raw files that contain natural language or unstructured data and then rendering it into a format that's usable in conjunction with a foundation model. Thanks.
Hey everyone, I'm George Matthew. I'm an investor at Insight Partners. We're about an $80 billion of assets under management investment management firm that does predominantly work in venture capital and private equity. I've been focused on everything related to investing in modern data stack, ML ops, and generative AI applications, which is where my focus has been for the last 3 years as an investor. So deployed about $1 billion of capital, predominantly in companies like Weights and Biases, which has become a very sort of centralized piece of what the ML ops stack looks like today. Looked at a number of things, what the modern data stack is, including deploying capital into a company called Astronomer, which is now the de facto solution for orchestration in the modern data stack, and then started to look at some of the application layer as it was evolving and was the lead investor in Jasper. So this is an area that's been near and dear to my heart, not only as an investor for the last 3 years, but as a builder. Prior to coming over to Insight, I was the CEO of an industrial drone company, and prior to that, I was the president of Alteryx, which I took public in 2017, and Insight and Clearlake just bought it back about a few months ago.
Cool. Hi everyone, I'm Luis Sezzi, CEO of Octo.ai. Octo.ai builds solutions for builders to build Gen AI applications with high efficiency, customizability, and reliability for production applications. We have a history in building open source AI systems for really, really high efficiency ML model deployments. Our users have on the order of millions of users in their own products, and we serve on the order of tens of billions of inferences a day today. So.
Hi everyone, I'm Vipul Vedprakash, co-founder and CEO of Together AI. We started together about 18 months ago with the assumption that there is going to be a big ecosystem around open source and custom AI models. So you had frontier model companies like OpenAI and now Anthropic and Google building their own platforms for training and serving and creating a developer platform around their models. What Together is doing this for everyone else. with a big focus on open source models. We allow our customers to start from these open models and customize them into with their enterprise data, and be able to sort of scale this to really high production grade quality at with a focus on cost efficiency. We have now tens of thousands of companies, from startups to enterprises, that are deploying models on our platform. We provide sort of we've also taken a full stack approach. So from data centers to GPUs to all the sort of AI science that we do to make model training and performance optimal is included in this platform. Our customers can just join in a serverless manner and start using this. So really focus on efficiency, performance, cost, and also a very smooth developer experience to onboard onto generative AI.
Amazing. Thank you all for being here. Just to level set a little bit, I know, George, you've done a lot of investing in the space. You're an operator in the space. How do maybe you think about categorizing, just a 30-second overview of just the AI infrastructure space and the different areas within it as we sort of think about it and talk about it up here?
Yeah, Julia, I think it's really hard to separate the AI infrastructure space without first talking about data.
Yeah.
And so first and foremost, I would say, it is an essential substrate to really think about what's happening in the modern data stack today. And that's a key area that, of course, we invested in not only just the elements of the modern data stack, whether it be the pipe of data coming into the modern data stack, how data management was occurring, how you reverse information back into applications and systems, but also just the orchestration and the observability, right? And so if you look at those layers as the fundamental substrate, then what you start to layer above that is what I think of as MLOps today, right? And there is a fair amount that's happening both in the sort of training around model building, as well as kind of bringing models into production at scale. And that's where I mentioned a company like Weights and Biases. Like, there is no foundation model today that ships without weights and biases, right? So OpenAI, Anthropic, Cohere, anyone who's building some of the open source models have de facto needed a product like weights and biases to handle everything related to the experiment tracking and parameter tuning and version controls surrounding delivering a model. And then more recently, we're starting to see this sort of layer emerge, which is basically LLM ops, right? Taking the ability to not build a custom model, but taking a transformer LLM and being able to deploy it at scale. And some of the teammates here on the panel are doing an incredible job, particularly in terms of building a platform for deployment in that regard. So that's kind of the infrastructure layer that we care a lot about as investors. And then, of course, there's a lot of applied use cases that have emerged in particularly generative AI, and there's great examples of that, like what the co-pilots are, what Jasper has recently done, or Writer has done. So there's a ton of sort of applied application level use cases as well.
Yep, I think that's a really good point, right? It's kind of building off of what we maybe term the modern data stack, and then how does that evolve to support AI efforts in addition to traditional data analytics. And I think part of what we're seeing also is a little bit of a tighter coupling there between the software and the hardware. And so, I don't know, maybe, Vipul, if you could talk a little bit about that and really, what we're seeing there and how sort of the AI data center looks a bit different from what you would typically see with a hyperscaler-focused data center.
Yeah, I think it's quite different from the CPU computing that we have done so far. The last 20 years of applications have been built on the kind of CRUD framework. If you compare how long it takes to do a generation, that's like fast ones, maybe like a second, and database queries a millisecond. So there is just this, many orders of magnitude of difference in the cost of doing generative AI, and it becomes really sort of imperative when you are thinking about deploying a feature to millions of users, that you think about, how this becomes more efficient, how this becomes more cost effective. And we're seeing this in, the power density required for a GPU rack compared to a CPU rack in a data center is 10 times, and there's 10 times more cooling. So you're seeing all this innovation happen at this layer around, power density and cooling, and the data centers are being distributed around the globe because you also don't have that much power and sort of localized in certain places. And it's flowing all the way up into the AI science, which allows us to do things 2 times faster, 10 times faster, and that has a real implication for the kind of application layer that is using these AI systems. So we're seeing this very kind of full stack innovation happening, which is quite different from the CPU applications.
Yep.
Yeah, I think I can add something to that. I mean, just open your eyes here. Like, it takes about 1 trillion compute operations to generate one image today. If you compare that to anything else to do with computers, it's orders of magnitude higher, right? So, and to add to what Vipul said, which was exactly right, so they see some super tight coupling between the software stack and the hardware underneath it. Like, you have to squeeze every single ounce of performance of your hardware substrates to be able to make an application viable, economically viable, or even usable by an end user. So, having this end-to-end optimized stack is not just a nice to have, it's something that's an enabler today. And even though there's a focus on data centers, like in the question here, just like says, let's not forget that there's a lot happening at the edge, at the edge of the network, right? So, and also these edge devices that you have on you, your laptop and your phone, are getting extremely capable too. So it seems clearly, and in fact, already generative AI models running on the edge today. I think we're going to see more and more of that. It's one more example of just getting compute for where it is and running AI where it runs best is something that's just part of the infrastructure.
So, let's pretend I'm within an organization, I'm setting up the infrastructure that I need to have success, right? Really achieving the ROI of AI in my organization. Maybe the first piece that I want to start with is the data, right? And that seems to be, I've talked about it a little bit last year, how data is really critical, right? You got to get it right. And it's interesting, Reddit recently filed their S1, and 10% of their revenue is actually coming from data that they are providing for LLM training. And so, clearly there's big use cases there. Brian, can you, give us a little bit more about what it means to really have LLM-ready data and how you guys are helping achieve that?
Sure. Yeah, riffing off a point that George was saying earlier about the modern data stack. Look, you have data engineering teams that grew up around it that speak in SQL and are dealing with data warehouses that they're moving data to and from and then serving applications. For the other 80% of the data that's unstructured, that really hasn't been utilized fully by those analytic applications like Microsoft Power BI and Tableau, but now are being cracked open through the use of large language models. It's interesting, within these organizations, you by and large have developers and data scientists that are doing it on their own without data engineering teams right now that speak in Python or are dealing with vector databases or vector-enabled databases and are using LLMs. And it's on them to do all the data engineering right now because the organizations haven't evolved to encompass all of this other data. And so the interesting thing that we've learned just through our path, our journey, and we should have known it going in, is that just data scientists and developers absolutely hate this data engineering work. It's a totally different culture. It's a totally different career path, and just culturally within an organization, it's resourced and nested in different parts of the stack. And so what you're seeing now among a very small number of the most sophisticated large enterprises is starting to think about horizontal investments around the modern data stack. There isn't a name for it yet, but which is around model serving, which is around cloud compute, which is around the data layer, all enabling different applications that can sit on top of that and be quickly test new models that are brought in, tested against identified use cases and applications that rest on top of that. From a data standpoint, look, the typical journey is that in an afternoon, somebody hacks together a LangChain retrieval augmented generation, RAG architecture, which is grab an LLM, grab LangChain, grab a Weaviate or Chroma, vector DB, and then just jam some data in there and see how it works. Step 2 is usually fine-tuning the model, and then step 3 is flowing data continuously into that vector DB with the fine-tuned model nested in that architecture. The critical bottleneck that at least we're just intensely focused on is that you can't just dump a PDF or a PowerPoint or a Gong recording into a vector DB. You need chunk vectorized JSON, cue everyone's eyes glazing over, but like you got to get to a JSON native if it's text, or at least an embedding representation of the images. If you're gonna like start cooking with fire here, if you're gonna have up-to-date information, an LLM that knows something about your organizations and start countering hallucinations. And so that first step is where we're focused on a horizontal data standpoint, on taking any unstructured data that enterprises generate every day. For large ones, it's 250,000 new files a day or more. How do you dog food all of that and then make that available to LLMs on the right-hand side of the equation? Well, you got to get it in the right format, got to get it cleaned, curated, and staged. And so that's how we're at least approaching it, Julia.
Got it. Yeah, and so, I mean, then step one, and then obviously step two is you really need to create and customize the AI models. And I don't know, Vipul, if you could give us a little more on how you guys are working on that together and how you can think about it potentially as a customer within an organization.
Yeah, and I think it's fascinating. We have, for many years before LLMs, just kind of ignored the unstructured data. It's been sort of second-class citizen in the data world, and now suddenly we can derive so much value out of it, but we are kind of lacking systems. The way we think about it is, there is adaptation of models with data, and there is a process of experimentation and discovery when you're doing training. We think about how to make that more and more efficient. One of the things that we sort of support is you can give us a lot of data, and we'll try to find the most important subset of it, which produces the best downstream model, and do this in a principled manner versus sort of just assigning some random weights to different categories. We have these serverless APIs where you can send files and get models on the other end. We see a lot our users build hundreds of these models, and then you benchmark them and evaluate them to find which is the best model. So there is this, I think part of it is going to be the experimentation setup and really using the LLMs and using this machinery to discover what is the best set of data and how that data should be applied to the problem.
Yep. And then once you've got the models, then it's about putting them into production and making sure they're running efficiently. And Luis, you know something about that.
We've been doing this for a little while. Yeah. So I mean, the first thing I'll say about efficiency is that the key thing is to balance speed, cost, and capacity. There's clear trade-offs between these. So in navigating that and making sure that you use the right set of SLA parameters for what you want in your application is really key to start from a viable place in terms of optimization. And then after that is really about, again, as I said before, turning your model into extremely efficient codes that makes the best use of the hardware underneath it and choose the right hardware for the given SLA. For example, if you think about batch applications, you're going to go get the data, unstructured data, run through Brian's solution, put it in a pot, and then later you're going to run a bunch of inferences in a batch way. You want to get throughput, but you don't care as much about latency. You want to get time to solution is what matters. But now, if you have a chatbot, you want to be responsive so humans stay engaged. So you want to optimize for latency as opposed to overall throughput and capacity. So you have to choose what you want to optimize for. But I want to tie that to something that Vipul just talked about and what you asked on customizability. I mean, we're seeing clearly this trend towards hyper customization of models. Like some of our customers have millions of users, and among those, hundreds of thousands of them have their own versions of models that have to be served at scale. So for each one of those, you might want to do slightly different optimizations and run all of that into the same finite hardware. So being able to optimize across a very large number of customized models and make them fit and be served efficiently in your infrastructure is a component of efficiency that's needed here in the platform level. And that's something that we offer solutions today, and we have several users doing that at scale. So,
how do you, I guess, go about advising people as they think about optimizing across a bunch of different parameters? And what are maybe the most common mistakes you see there, and how do you avoid those as an AI leader within an organization?
Well, the first mistake is not using our solution. So come to us; they'll do it for you. I mean, so it's hard. I mean, look, I've been an academic in this space for a while. I guess more than half of my life has been about writing really high-performance linear algebra libraries, to make it run on a broad range of hardware. This is something that takes a kind of special taste. Just say that the first thing is know what you're optimizing for, as I said before. You care about latency, you care about throughput, and then pick a system that navigates these parameters for you. I mean, there's layers of abstraction work really well for a reason. Is because you want to focus on the thing that matters to you and use the very best thing underneath it to support it, right? So I feel like right now there's a whole lot of do-it-yourself and optimizations that's leading to longer time to solution and suboptimal results. So just say like, don't be afraid of using, and a lot of those are open source, but we open source a lot of what we do, and we actually encourage people to go and build with it. And it's great to see that being used at scale. But if you're doing this in production, what you care about is just knowing what the parameters are and let the system do it for you, right?
So that actually leads me, into as you're thinking about how you're, selecting solutions to use. I think there's a lot of, different ways you can go and kind of different debates within the space. It's very, rapidly evolving. And one of those, right, is the open source versus closed source. And, how, I guess, anyone's opinion on this, how can you think about that as you're thinking about selecting solutions that you're using within an enterprise?
I would say a lot of what we're seeing is a hybrid approach, where you have, multiple use cases. Some of them have closed source, some of them have open source. But one of the things that I think on the open source side, you have more control, more transparency, more control on the cost side. And when companies are scaling up use cases, it's a very common thing that we see is an application that's built on GPT-4, but when it's about to be deployed, a better solution is to fine-tune a smaller model. You get better accuracy, and you get much better performance. So I think it's going to be a combination, of custom models, of open models, of fine-tuned models, of closed models, and the enterprise sort of adoption of this is going to be messy and complex like that versus picking a stream.
One nuance I'd just add on that is that I don't even think about as much anymore about open versus closed source. Yeah. I really first and foremost look at it as large models and small models, and there's a tremendous amount of benefit, as Vipul was indicating, to looking at things from a use case standpoint and where you deploy and when you deploy perhaps a smaller model, right? I mean, one of the things that we're noticing now is like large models, particularly coming into production, is really expensive, right? And the inference around that gets really costly. And when you look at an opportunity to fine-tune a smaller model, the inference cost can be radically managed in a way that you can't necessarily control as well with a larger model. So I think this is where there's going to be plenty of reasons to have multiple models come into production when you're kind of bringing a vertical specific solution, a domain specific solution to market. And a lot of it is just like trying out and seeing what works.
Awesome. Yeah. They're doing coverage of this panel, so
yeah.
Got the helicopters circling overhead.
To add to that, briefly, a quick thing is that one thing that's clear is that people are already building with collection of models anyways, and this collection is becoming more and more, models that are just small. But I do think that if it's open, there's a lot of inherent advantages of auditability, control, adaptability, and so on. One thing that's interesting that's we do that, I know Together does that as well, and others, is that we made fully OpenAI compatible API, so you can move literally with a couple lines of code. If you run an OpenAI model, if you found an open source model, or you customize one that does that has the right quality, you can flip over the traffic in a couple of lines of code. So zooming way out, I think what's interesting here is how do you select the right model for the right task that has the properties that you want, and more you can do that automatically. So helping customers stay future-proof and on top of the models that has the right properties for them is a huge opportunity, and it's happening right now. So.
Yep, makes total sense. Yeah, and I guess another piece of that, right, is how much is fine-tuning an existing model versus, right, how much is really building a custom model, and how, enterprise customers can think about that, right, in terms of where each one is the best solution for them.
On this, it's funny, like 12 months ago, we were all worried that OpenAI was going to have a complete monopoly over the LLM space, and here we are 12 months later talking about we should use 7 billion, fine-tune 7 billion parameter models that are dirt cheap to run, and there's like 1,000 options, and we should hot swap them in and out, or automatic recommenders that can, different use cases can steer work to different ones. And not to pick on JP Morgan, but JP Morgan spent a bunch of money on Finance GPT last year, and I think what we found as an industry is that those capital investments, those amortized over weeks, not years, and that those models are just coming out so quickly that that are either for specialized use cases or for broad use cases. That what you want is a stack where you can trade them in and out really quickly, and then fine tune them very easily. And so if you have your data layer in order, well, it enables it. If you have the model serving and fine-tuning layer in order, well, okay, a new Gemini model came out, Claude 3 came out, Llama 3, whenever that comes out, that'll be available. Being able to serve that and then fine-tune it and test it quickly against different use cases, I think that speed to use case and speed to production, that's the key variable here that a lot of us are going to focus on.
Yeah.
So to live in that world, right? Live in the world where you have that. What are kind of the key changes that you see to maybe the modern data stack, right? We've talked about that for years now. How does that evolve? What are the key pieces that remain mission critical? Which new pieces become mission critical within the stack to kind of support that version of the world?
So Brian alluded to a few points earlier. I mean, most of what was built in the modern data stack up to this point was really well suited for structured data. And now we have this reasoning engine that does incredibly well with unstructured data, right? And so I think over time, we're going to start to see the underlying data stack itself be much more supportive for both unstructured, semi-structured, and structured data to flow into generative AI-based applications like the LLM-based ones that we're seeing today. And in that regard, how do you just make it easier to send tokens into models? That's just not an easy task right now with the modern data stack as it stands today. So we're going to see a decent amount of evolution, because I think everyone realizes that there's a tremendous amount of benefit of just coagulating the data that the modern data stack has at least done on the structured data side for the last, a decade or so. Certainly benefited Snowflake and Databricks. Now they're going to have to, and the folks that are surrounding them are going to have to be highly supportive of how generative AI applications are built.
Yeah. Go ahead.
I think this is absolutely right. One of the things that we are seeing, we published this data set called Red Pajama V2. It has 30 trillion tokens made from the web. It's a completely open data set. And we published version 1 before that. Some of the things that we learned during that process was we want to create things like quality signals with every document, being able to create, provide tokenized versions so that you can throw them into the model right away. We have these methods where you can select, given a small number of documents, you can select the sort of semantic space around it. And these operations are sort of fundamental to the downstream experimentation process that happens in fine-tuning or designing your models. I see more and more of the kind of data stack evolving to incorporate these ideas, and Brian's building unstructured. It's sort of in that direction of how do we think about all this amazing unstructured data that now we can get value out of.
And by the way, the smart incumbents are also doing this right now, right? So if you think about what Astronomer has been able to do around Airflow, they're now evolving to have better support for LLMs, right? What Excel Data, for instance, has been doing around data observability, the roadmap is clearly going towards LLMs. So I think it's as much happening in some of the new innovation on the sort of top layer of LLM ops, as well as some of the existing providers, particularly in the modern data stack, are continuing to evolve their solutions very quickly.
Yeah. Two things quickly. You asked what changed in the last 18 months. I'd say the first one is now cost of compute is top of mind. I don't think it was top of mind a year and a half ago. Now it is. And then the second thing is, I feel like looking at model parameters as a new data asset is becoming clear. Like before, you have data and you have models, like you don't change the model as much. But now with hyper customization, I mean, there's one entity in our platform. It's called Model Asset Lake, which all it does, it manages a very large set of models that you serve from, and that's becoming a new data asset that you have to keep track of and see whether it's getting stale or not. So, yeah.
So, Gemini models came out in multi-million size token window. What Luis is talking about that iron triangle of speed, cost, and capacity, this matters a huge amount, because at the end of the day, the way that you can maximize that is by feeding the LLM those tokens that George was talking about. Feed it the fewest number of tokens as quickly as possible.
Right.
And that maximizes the likelihood of success. That's performance. That drives down cost, right? And so I'm very skeptical of these infinite context window models that they'll gain widespread enterprise adoption, because at the end of the day, you can't break that triangle. You can just try and optimize on that. And you optimize it by, in the modern data stack, it was going and finding the right rows and columns in these relational databases and extracting it and then delivering it as efficiently as possible. Here you have to do that, but then you also have to go into typically a vector store right now, or a vector-enabled store like what Mongo is doing, and go and do a sniper shot in there and grab just the chunks that you want and just the pieces of the chunk that you want, and then bring that back to the context window. That's where a lot of this, we're doing co-development with a bunch of different database providers. We're doing co-development on retrieval models. That's where there's a lot of frothiness right now in what that model is going to look like in terms of the data stack.
Well, one point on that, I don't think there's any, I may have missed research in the last month on this topic, but up to the last month, there's no proof that these large context windows are actually good at understanding anything but the first few pages and the last pages of what's thrown into a context window. So maybe that changed in the last month that I missed, but
it did.
What that?
It did.
Okay, I missed that. Okay, so clearly you should highlight that. But up to last month, there was no proof that you could see those context windows really performing the way they did. But you should pick up.
Absolutely. No,
so
I was fascinated by this paper too. There was a paper about 4 months ago that showed that, I think Percy Liang's paper said, okay, so you have a long window, it does really well if it's related to the beginning and the end, but not in the middle, but now that get normalized. And now there's a lot of stuff, people are doing amazing things with just in context learning now, that I feel like it's going to put in question whether or not you're going to do as much fine tuning. But again, it's trade-off in cost, right? If you're going to have a larger context, you have to go and rebootstrap the context all the time, So it's a question of flexibility versus additional costs, right? So
it really is a fast-moving space. So
yeah, you missed some papers for a month, right?
Yeah,
I didn't mean to call you out.
No, I figured I'd missed something, right? So
things may have changed while we are on this panel. We haven't looked at it.
yeah, there was actually something published 5 minutes ago.
I do think the long context is a very interesting and important area of research. The fact that these models they have very limited memory is definitely problematic. If we can figure out a way in which we can generalize over long context and make it cheaper, it's really not going to work at the current sort of cost for just maybe a few research requests. I think that could be fairly revolutionary and could have, really big impact on the kind of data stack future, because you really don't have to, at that point, think about structuring your data at all.
And one very specific case having impact right now is in code generation. Code generation models that have a longer context window, the more context window for the code you do, the better job it does at generating code that has lower chance of bug and being more on point. So.
Yep. So I guess switching gears just a little bit and talking about something that's probably relevant to everyone in this room, dollars and cents. How do you think about really the ROI, right? And obviously in a space that's this rapidly evolving and where there are so many different moving puzzle pieces, how do you communicate, right, to potential customers? Here, this is sort of the return on investment that you're receiving especially when you don't have control over the full, stack of everything. How does that work? And where do you see over time margins accruing within this space?
I think we are seeing, for many of our customers who have large generative AI programs and features now, they are seeing a lot of leverage internally, in automation, in delegative tasks, in creating new features that are stickier. So this is going to be a sort of, per industry process of discovery. And the companies that are seeing leverage are seeing very, very high leverage, and it is really sort of essential for them to try to take this across the enterprise wherever they can apply it. I think we're very early in this process. There is a sort of creative act required on top of the models to figure out how to sort of couple the power of these to particular processes and products, and we'll see more of that. And as we've been saying, it is expensive, and so on the other side, we really need to find ways to make it cheaper to deploy it at scale, and both these things are, I think, happening now.
Well, just to comment that, if you're asking now margins in our space in Gen AI infrastructure in general, the way, we would make a margin, and I think I can speak for other folks in the panel here, is about, first of all, efficiency. You charge based on the output that you do, but then the more efficiently you provide that output, the larger margin opportunities at the base level. But that's not sufficient. I feel like there's a drive, there's definitely margin squeeze out there, because it's in NVIDIA's best interest for everyone to make the most efficient use of their hardware. So you have to assume that's going to get normalized. So the margins has to come from the rest of the system, which is offering things that really matters, like really high reliability, customizability, ability to go and abide to their privacy policies and so on. And even that I don't think is sufficient either. The key is just to pick, what are some of the higher level features that you can offer, at the API, going in an API that's beyond just wrapping the model by providing, things that are closer to a solution. For example, background removal as opposed to calling a bunch of image gen models, or RAG APIs as opposed to stitching the models together, and offering higher level APIs that gives more margin opportunities where I think it needs to go. Otherwise, I just don't see where the margins are going to come from. So,
yeah, I don't know how your experience is. I would say we provide fairly aggressive pricing, and we have fairly good margins. So and efficiency, as Louis is saying, it sort of drives the margins. We do see if the prices go down, it sort of opens up entirely new use cases and markets that become profitable. So we do want to make this technology cheaper. As an industry, we should be trying to do that. And there's just, we are probably 0.1% adoption right now.
Exactly. Yeah, so, and then there's Jevons paradox here as well. You make it, even if you reduce your margin, the volume goes up more than makes up for the overall, absolute amount, right? So Jevons paradox plays a very clear role here, so.
On the investing side, George, how are you thinking about the space, and what's most interesting to you as you try and kind of parse maybe the signal through the noise?
Yeah, there's a few areas that I'm really focused on right now. One, on the margin topic, interestingly, I'm really fascinated by how much some of the AI agent-based technologies that are emerging are really impacting margins. I don't know if anyone noticed the Klarna update. They literally took their entire customer service organization, which is about 700 people, and turned it into a generative support model. And that literally, speaking of margins, had a tremendous impact on how Klarna is running its business, and certainly updated on their quarterly update. So I'm starting to look at that area, pretty deeply, where you can start to see agent-based technologies that are full stack in nature, that can operate as almost sort of an AI workforce. We invested in a company out of Australia called Relevance AI, and their entire focus is building entire AI workforces, because they provide a full stack capability, as call it smart agents for reasoning purposes. In their first use cases is I hate to say this, but replacing BDRs. So just not having inbound BDRs any longer, because they're now using a generative technology agent for that. Another area I'm really focused on right now is just kind of the responsible AI frontier. So we led the investment into Fiddler from an observability standpoint, but we're now starting to look at areas where you can take the changes in the regulations that are continuing to emerge, and how do you apply that from a GRC standpoint, a governance risk compliance standpoint. And a third area that I'm targeting right now, so this is basically everywhere I'm investing, so feel free to come up and talk to me afterwards. The third area I'm really targeting right now is just how reinforcement learning works. And so if we think about both RLAIF and RLHF as sort of embedded frameworks that are available in models like Anthropic, how do you tease that out and provide that as a platform? So that's an area of pretty strong interest for me right now.
Awesome. And you talked about a little bit on the use case side. What for each of you, what's the most interesting use case that you've seen? Curious, right? We've talked a lot about the nitty-gritty of the infrastructure, but on more of the application and the use case side.
I have a sweet spot for the use in biology. I just feel like what's happening, the ability to, do molecular engineering is just studying. There was a presentation yesterday here, on the generative bio world. Like, just think about this, right? Just like AI-assisted coding tools enable more humans to program computers, even though they don't understand computers. Now we're seeing, AI ways for you to program biology, and we don't even understand fully how biology works. So it's enabling a whole sort of, flood of new ideas that can be evaluated and tested very quickly. I think that's going to change the world. And that's the one that I can't imagine a better one. So I hope I'll hear another ones here, but.
Absolutely. I think applying these to actual, physical languages is going to produce an immense amount of value. Things that are right now really sort of stunning and valuable to see are these fully delegative agent workflows where, companies are building software engineers and support researchers, but doing the entire sort of life cycle. You can talk to them, and they will, they're doing this. I think this will create very significant enterprise value.
I think on our side, opposite end of the spectrum, we're working with a big CPG company. They had us ingest all of their product development and product ideation work over the last 20 years. And they were trying to do RAG on it, but they wanted to help ramping up the amount of hallucinations of the model to help with idea generation. And so I think that's that's emblematic of a broader point. It's like a oft repeated phrase that 2023 was the year of prototyping. This is the year of production. I'm very skeptical that very many people are going to get into production. Agents are still extremely hard. Information retrieval, one of the reasons Glean's doing so well is because information retrieval through RAG actually works pretty well. Everything else, you can do some cool demos, but getting it into production with folks that aren't technical users, almost 99% failure rate still for all of this. There's just too many micro decisions. It's really hard to optimize across these really complex systems. And that the use cases that err towards deliberate hallucination are the ones that are making it into production. The ones that actually are more tethered around process automation, business process automation, and acceleration. Those are still really, really hard. And I think the models got to get bigger. The architecture, models have to get better. The architectures have to improve. The retrieval models have to, all of this, getting from 90 to 92 to 93%, and so on and so forth, is going to be really, really hard. And so I wouldn't be surprised if a lot of this spilled over into 2025 and 2026 before you started to see more stories like the 700 person customer support that are fully automated. I think it's going to be a long journey for most companies.
All right, well, we're getting close on time, but I'm going to ask you all a final question, and I'll ask you for your hot take. It can be predictive or just a hot take on the space. And if you're right, the good news is then you can point to it, and we have it on video somewhere. And if you're wrong, nobody will remember. So space is moving that fast. So everyone gives one hot take, controversial as you want.
I think my hot take probably would be that retrieval augmentation systems probably won't exist in I don't know what the time frame is, but we will. I am more optimistic about the unstructured, longer context systems becoming good enough.
So my hot take is, like, we keep talking about how AI is changing the world, but we keep forgetting that probably touching only, 1%, 2% of the world's population. I want to think about what would it take for us to actually serve half of the humanity, half of humanity with AI services, something that we are just so far behind there. And yet, at the same time, there's this crazy demonstrations like, oh, here, how fast you can run this, when fundamentally that's being so incredibly inefficient that it almost hurts. And yet people are getting impressed and thinking that's going to change the world. Like, if you don't think about efficiency, it's just not going to reach a meaningful humanity level impact. So,
my hot take is that LLMs are going to continue to get smaller and more capable, all the way to the point that we'll likely end up having personal LLMs all the way to probably the iOS device. So my hot take is Apple's going to release an LLM this year.
Oh, okay.
Yeah. I think on my end, I agree with everything the other panelists said. I think probably the most interesting developments, if we're going to see big shifts forward, is going to be on the hardware side. I think like Grok's really interesting, but then also like the move from A100s to H100s, and then further development. It's going to be diminishing marginal returns on LLMs. It's going to be about optimization in single-digit percentages, and given the amount of investment going on there, I think it'll be really interesting to watch the hardware space over the next 12 months.
yeah.
Awesome. Well, thank you all so much for joining us today. And anyone interested in investing or building in the space, come chat with us after. We appreciate you all in the audience.
All right, thank you.